Okay, for example 8, they're asking us to use the frequency distribution table we just created to create an expanded frequency distribution table. Notice we have the frequency F. These are just the numbers I just got a moment ago. I've thrown out the tally mark column just to save some space. If the tally mark column's there, it's no harm. It's just, again, it just takes up space in your paper. So if I was doing a problem from scratch and I had to do the frequency distribution table, I'd have the tally marks, the frequency. I'd go ahead and put these extra 2 intervals on to the chart that's already made, as opposed to creating a new chart, is what I would do. Notice I've also added this extra row at the bottom here. I'll show you why in a moment. All right. And it asks us to use the expanded frequency distribution to calculate the mean number of hours worked on the crankshaft. Now, there's the mean number of hours. Obviously, we can add up all the numbers, divide by 40, hit equals, and that's the mean, right? When you have a large set of data like this, it gets to be a little tedious to type in that many numbers. So we can get an approximate mean that's pretty close to the right answer. That's probably going to be good enough. It might be off by just a smidge, but it's not going to be off by a whole lot. And the way we do this is using these intervals, we're going to find the midpoint. And the midpoint is just halfway between the numbers here. So halfway between 10 and 19 is just 10 plus 19 divided by 2. That's 14.5. And if I'm typing this in a calculator, I'm going to type in parentheses 10 plus 19 and parentheses divided by 2. Or I can mentally add 10 and 19, 29 divided by 2. Either way, it's 14.5. If I punch in my calculator 10 plus 19, no parentheses divided by 2, notice we get 19.5, which is not halfway between 10 and 19. So be careful that calculator parentheses usage is happening. If we do that for each of these sets, 49 divided by 2 is 24.5. 69 divided by 2 is 34.5. 89 divided by 2 is 44.5. Does anybody see a pattern happening here? Each number is how much bigger? 10. So it goes up by 10. So 54.5, 64.5, 74.5. So all you're doing to make that midpoint column is taking these numbers and finding halfway. Add them up, divide by 2. Okay. If you've got a pattern to this intervals, which you should, there'll be a pattern to the midpoints as well. So once you establish that pattern, you just use that pattern to get the rest of them, or again, you can just keep adding up, dividing by 2. Make sure you add them both, divide the sum by 2. For the product is just F times M. So F is this column, M is this column. So to get the product, I'm just going to take this number times that number. All right, so get a calculator and we type in 6 times 14.5. And the numbers in the 10 to 19 column are around 87. And this is not exact, it's close. All right, that's what we're looking for, is closeness. And we have a large set of data. We don't want to find the sum of 8,000 numbers, right? We can do this frequency distribution, have 8,000 numbers identified here, have some midpoints. 8 times 24.5 is 824, no, that's not right. 8 times 24.5 equals not 196. 12 times 34.5 is 414. 7 times 44.5 is 311.5. 4 times 54.5 is 218. 2 times 64.5 is 129. 74.5 times 1 is 74.5. All right, is everybody comfortable with how to get all those numbers for the chart? Okay. And again, if you were doing your own from scratch, you'd have a tally column, your frequency. I would just include these two at the end of the chart that's already been made. Don't make a second chart just to get rid of the tally column. All right, so what I'm going to do here to find the mean is I have to know this total sum, and I need to know the total number of numbers. Well, 87 represents the sum of these 6 numbers, 196 the sum of these 8 numbers, 414 the sum of those 12 numbers. Again, not exactly right, but close enough for us to say that's pretty close. So if I add all these numbers up, that's going to be the total sum. Total. All right. So if I take my calculator and just punch those 7 numbers in, 87 plus 196 plus 414 plus 311.5 plus 218 plus 129 plus 74.5, that comes out to plus 74.5, 87, 196, 414, 311.2, yeah, so 1,430? Again, we've already established the number of numbers is 40, but just you want to add these up to see how many numbers there are. So if you didn't already know, you could do 6 plus 8 plus 12 plus 7 plus 4 plus 2 plus 1 equals, and it's 40 numbers. So total number is up here 40. All right. Mean is how much the sum is divided by how many numbers there are. So the mean number of hours worked based on the frequency table is going to be, I'm going to put M for mean, is going to be 1,430 divided by 40. Whatever that comes out to. 1,430 divided by 40 comes out to 35.75 hours.